If you turn to page 7 in your note package, we get to the exponent laws. We've learned the definition of what a power is. A power is repeated multiplication. It has a base and it has an exponent. But then when we do math with powers, there's some shortcuts that we can do to make the math faster. But it's important to understand why those shortcuts are there and how they work. And those shortcuts are called the exponent laws. The first one that we look at is the product law. And we start to discover the product law by writing things in expanded form. So if you have 5 to the 4 and 5 cubed, and you wanted to write that in expanded form, I'm going to put brackets here. For 5 to the 4 in expanded form, that would be 5. Tell me when to stop. Now stop. Why are there 4 of them? Because the exponent was 4. For 5 cubed, that would be 5 times 5 times 5. If I wrote 3 cubed, 3 times 3 times 3, and 3 to the 7, 1, 2, 3, 4, 5, 6, 7 of them.
May I please borrow a pencil? It's okay, someone's giving me one. Me too.
Now once we learn the product rule, you're going to say 5 to the 4 times 5 to the 3 is equal to 5 to the 7. And 3 to the 3 times 3 to the 7 is equal to 3 to the 10. So Justin was able to say the 10 before I wrote it. See if you can figure out what he saw. You can't tell anyone. You're not allowed to tell anyone. Yeah, don't tell. If you figured it out, don't tell anyone. Okay? It's kind of mean. I know. Just trying to be mean today.
Yeah, I found it out.
Okay? Now, Duncan is saying it's pretty easy to figure out, and yet lots of grade 9 students have trouble with the exponent laws. The reason they have trouble with the exponent laws is they try to remember them without knowing why they happen. But if you look at what the definition of a power is, right, you write it in expanded form, then the rule becomes relatively easy. Okay? If I gave you another one. Oh, we used 5 already. I'll choose a new number. 7 to the 3 times 7 to the 4. You would get 7 to the 7. What would happen if I did 3 times 3 to the 5? I would get, no, write it in expanded form.
9. Was that right?
If I write it in expanded form, I have a 3. And then I have 5 of them. What's that going to equal?
Whoever said sister should.
So if you ever forget an exponent rule or exponent law, you can always go back to the definition and refigure it out. The rule here that we're going to learn, now if I told you couldn't say it to anybody else, how did you figure out this was 5 to the 7? Yeah, if there's 4 of them there and 3 of them there, there's going to be 7 of them all multiplied together. The shortcut for the exponent law is if you're multiplying powers with the same base, you can just add the exponents, you get 5 to the 7.
I'm confused, Mr. J. Hart. I'm sorry for being honest, everyone. I'm confused.
So here with the second one, are you okay with 3 cubed being 3 times 3 times 3?
Yes.
Okay, and 3 to the 7 being 3 times 3 times 3 times 3 times 3 times 3 times 3.
21.
No, not 21. It's going to be bigger than that.
21.
There's 7 3s all multiplied together. And if I count how many 3s are all multiplied together in the end,
10.
there's 10 of them.
But why is this so 3? Shouldn't it be
Because it's, what does a power mean? This is your base, this is your exponent. It means repeated multiplication. Do you have a 3 multiplied by itself 10 times?
Yes.
Yes, you do.
21.
So how do we write the rule? This is how the rule is written. When the rule is written with algebra,
You guys are being loud.
when the rule is written with algebra, they use letters to say there could be any numbers here. And all you need to do is add those exponents together. So the product law in words says when you multiply 2 powers with the same base, you can add the exponents and keep the base the same. Okay? Simplify if possible and use the product law. I have written in here, and you can add that as well to your notes, to write as a single power. How did you do? Did you get 6 to the 7? Did you get, in this one, 4 to the 2 and 4 to the 9 makes 4 to the 11, and then you have one more 4. There would be 12 of them, giving you 4 to the 12. What's the difference here? In E, we're adding, you could get an answer for this, but you can't write as a single power. And the question said write as a single power, so we're just going to write not possible right now. Okay. F is a little bit tricky. F is a little bit tricky because the negative isn't with the 4. So if I wrote this in expanded form, there would be one negative and then 4 4s, one negative, so when things get, if you're a little bit unsure, write it out in expanded form. First of all, what's a negative times a negative going to be? Positive. And then how many 5s do I have in the end? So the answer to this one is positive 5 to the 10. Can you see yourself being tempted to write negative 5 to the 10? When would it be negative 5 to the 10? If the question looked like this. If the question looked like that, then it would be negative 5 to the 10. Notice the subtle difference. Okay, this one is 2 to the 8. The next one, you could get an answer with your calculator, but to write this as a single power is not possible. This one, there would be 15 threes in the end. For this one, you could put these together and get 2 to the 6, and you could put those together to get 3 to the 8, but then after that, to write it as a single power, it's not possible. Maybe if you turn facing the board, that would be helpful. Oh. Okay. So again, this one with the adding here, with this one will be not possible either to write as a single power. Again, you could type it into your calculator and get an answer, but you can't write it as a single power.
So when it's adding, it's not possible?
If you're trying to write it as a single power, when it's adding, it's not possible. And that's why this is called the product rule, because it only works if you're multiplying powers with the same base. So in L, we're multiplying, but the powers have different bases. This one is not possible either. Okay, so I have some questions for you to work on.